Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 743 network delay time. We're told that we're given a network of n nodes labeled from 1 to n, and we're also given times, which is a list of travel times as directed edges. So we're given u, v, and w, where u is a source node, v is a target node, and w is the time it takes for the signal to travel from source to target, also known as the wait. And we want to send a signal. We're going to be send a signal from a given node, which is going to be k, and we need to return the minimum time it takes for all the nodes to receive that signal. So to solve this problem, and basically we want to return -1 if not all the signals, not all the nodes can return -1. So let's say we had a node which was separate from the graph. So how can we solve this problem? Well, this is a classic problem which requires Dijkstra's algorithm. And Dijkstra's algorithm, it's a complex algorithm, and the best way that I kind of wrapped my head around it was thinking of Dijkstra's algorithm as basically just as breadth first search with a min heap as opposed to a queue. And it will make more sense as we get coding. But the way we want to solve this problem is starting off from k and kind of do ripples or like frontiers, just as we would do any other breadth first search problem. So each layer we append nodes to our queue, or in this case to our min heap, and track the time. So let's actually get coding up. So we're going to be using Python, and let's actually create our adjacency list first. So let's create adjacency list. So to do that, we want to set our adjacency list equal to a dictionary, and this dictionary is going to be dictionary of lists. And we can say for u, v, and w in times adjacency list u dot append, and we're going to append a tuple of v and w, v being the target node and w being the weight. So that's our adjacency list built. We don't do it both ways because this is a directed graph, so each node only goes, the signal only travels one way as opposed to bidirectionally or omnidirectionally. So that's our adjacency list created. Now let's actually do breadth first search. So to actually do breadth first search, we want to set our time equal to 0. Initially, this is what we're going to return, the minimum time it takes. We want to create our min heap, which is gonna initially just take in a tuple of 0, which is going to be the weight, and the node, which is going to be k, which is passed in, and a visited set. And this is going to make sure we don't keep, if there's a cycle, we don't keep going round and round in that cycle and never returning anything. We want to detect cycles and prevent those cycles from affecting our problem. So, our solution. So let's now say while the min heap is not empty. So while min heap is not empty, let's get our weight and our node. So I'm going to say weight 1 and node 1, just because if I were to use node, I would put n, and n is given as the number of nodes in our graph. So we're just going to use weight 1 and n1, and that's going to be equal to heap pop from our heap, and we want to pass in our min heap. We're going to say heap q.heap pop and pass in our min heap. And if the weight, or actually no, if the node is in our visited set, then we're just going to continue. We don't want to do anything with this now because we've already come across it. Otherwise, we want to add to our visited set our node, and then we can set time equal to the maximum of time or the weight, so whichever one is bigger. And then we can do breadth first search on all the neighbors. So we can say for node 2 and weight 2 of, or in adjacency list and pass in node 1, if node 2 is not in our visited set, then we can say heap, we can push these neighbors to our heap. So we can say heap queue.heap push, pass in our min heap, and then pass in, and now here we want to pass in the weight, the sum of weight 1 and weight 2, because if we were to, in this problem, we'd have 1 over here and then 2 over here would be the sum. So we want to increment our weight by summing up the two weights together, and we also want to pass in the node. So that's our breadth first search while loop done, and then all we have to do is return t if the length of our visited set is equal to n. It means that we have, we've visited all the nodes. If we didn't visit node, let's say there was a node which was not attached to our graph, in that case we would just return -1. Let's submit our code and check if this works. And we get the wrong answer. Why do we get the wrong answer? Let's look in the code. So we're creating our adjacency list. Okay, I want to add in weight 1, not weight. Okay, and that's a solution. So that's our solution done, guys. So it's a bit confusing to wrap your head around, but once you understand that it's basically just breadth first search with a min heap as opposed to a queue, it makes understanding Dijkstra's algorithm a lot more simpler. So I hope you guys enjoyed this video, guys, and with that being said, I will catch you in the next one.